Hello and welcome back. So here we are going to explore how to do rotations on a coordinate grid. And ladies and gentlemen, here's how I'm going to explain it. Because of the fact that we're on a coordinate grid, I'm going to use the coordinate grid and not really any other tools, because rotations can be done with a compass and with a ruler and a straight edge. But because of the fact that we're on a coordinate grid, let's take advantage of that and talk about how we can do rotations by breaking up our direction into x and y coordinates, into x and y components. So first, let's go ahead and take a look at A here. Our value of A is 3 points by our x and 1 point by our y. Ooh, that's really thin here. Let's go ahead and make that a little bit thicker. Text highlighter. That should do it, right? So 3 by our x and 1 by our y. Hold on one second. Okay. Technical issues. I'll be right back. Round 2. So our value of A is positive 3 on our x and negative 1 on our y. So when we consider that and we apply a rotation, what essentially I'm saying is that for our point A, which is currently at 3, negative 1, I'm taking those directions, right and down, and I'm rotating each of those by 90 degrees, or however far our rotation is going to be. If I want to rotate by 90 degrees, I'm leaving it positive. That tells us it's counterclockwise, that I'm taking each of my directions and each of my distances and rotating them by 90 degrees. And so for A prime is going to have now the direction up and the direction right by 3 and 1. And so A prime is going to now go only over 1 and then up 1, 2, 3. And so A prime is going to be right here. And if you're following the rules, you can see why x and y switch spots and why their symbols change. Here for A prime, what's up and down? Our y value. So now I'm going up 3, and now that negative 1, because I'm going to the right, is a positive 1x. So that's why we're able to count and keep track of what moves and where. And so, ladies and gentlemen, A ends up at A prime for those reasons. We're able to count how far A goes and how far B goes in order to really pull that off. So for B, we're going over 1, 2, 3, 4, 5. So we have the 6 there, and then we have down 1, 2, 3. And so for our value of B, we are over 7 on our x, down 3 on our y, which means that's to the right and it's down. Once again, rotate counterclockwise by 90 degrees. Now our value of B is over 3. Imagine, another way to think about it is, imagine this L shape, this bracket shape that we have right here, being rotated up. So now we're going up 7, 1, 2, 3, 4, 5, 6, 7, and then over 1, 2, 3. That's where our point B prime is going to be. And so you're able to do that to all of your points and have them rotate by that amount. So for C over here, we're going over 4 and down 5. So what was over 4 is now going to be up 4. And what was down 5 is now going to be to the right 5. So we're able to go up our 4, 1, 2, 3, 4, then over 5, 1, 2, 3, 4, 5, and we're able to get to our C prime. And ladies and gentlemen, we have our rotated shape. ABC is now rotated to A prime, B prime, C prime. This is pretty nice when your center of rotation is at the origin, and the origin is 0, 0. If you're looking at a diagram that is not at the center, then it becomes a little hard to track and keep a track of the actual numbers themselves, and it makes sense to me to do it primarily graphically. And so let's say we have ourselves a triangle down here. No, thank you. And I'll name this A. Actually, you know what? Let's have fun with this one. Let's call this one RAM. Go Rams! Woo! So there's RAM, and so we want to rotate this around point P. Now, ladies and gentlemen, thinking about what we talked about before, let's go ahead and rotate this 180 degrees. And let's think about those directions that we were talking about a second ago. For point R, to rotate 180 degrees means we're looking at our directions being flipped, right? And so for our point P, we're going 1, 2, 3, 4, 5 from P to the left, which means when we rotate 180 degrees, what was left is now right. So we want to go 1, 2, 3, 4, 5 to the right. Now for R, when we go down 1, rotate 180 degrees, what's 180 degrees from down? Up. So we want to go up 1. So our point for R prime is here. And then you can continue that for the rest of our points as well. So let's go ahead and do that for A also. So A is still over 5. So we want to go over 5. 5 to the left, rotate 180 degrees. That direction is flipped. Not really flipped, but twisted from left to right. And then, instead of down, we're going up. And what's 180 degrees of up? Down by 1. So then we have our point for A prime. And now for M, let's go ahead and use this wonderful, wonderful cyan color here. M is only going over 2. No thank you, sticky keys. Is only going over 2 to the left, which means we only want to go over 2 to the right. And then we're going down the 1 still, which means we're going up 1 to rotate that 180 degrees. So M prime ends here, which means our image, RAM prime, looks like this, which is indeed rotated 180 degrees. So thinking about it graphically, not necessarily on the coordinate plane with your actual values of A, B, and C as the points, but graphically thinking about how far over, how far up and down from the center you're going, the X and Y coordinates, will help you keep track of where your points are beginning and ending a little bit easier. Because of course, now we can look at M, R, and A and actually determine what their coordinate values are when we need to. For the value of R, as an example, I'm going over from the origin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So r is 12 on our x and -2 on our y. And we can count that just on our coordinate grid, looking at a point that's not on the center to perform our rotations. So, ladies and gentlemen, I hope that made sense and I hope that helped. If not, please email me